Welcome to Noble Team YouTube channel, and in today's class we want to look into JAMB past question on pH and pOH calculation. Now, if you are sitting to write for exam or you are preparing to write a JAMB exam, you have to pay close attention because JAMB normally bring out up to 3 or 4 questions from this topic, and you can't escape any question from it. Now, this is the class content of it, which is definition of pH and pOH, relationship between pH to pOH. Now, exam key points to take notes on pH and pOH. Then solving of 8 solid JAMB past questions. Now, in this JAMB past question, we do be solving 5. I'll give you 3 as an assignment. You solve it and submit it in the comment box. Now, my name is Noble, CEO of Noble Team, and before we start, make sure that you yourself, you watching me over there, you have either your earpiece, your earpod, or your headset, because it will reduce distraction and also get your writing materials, because you are going to be gaining a lot from this. Now, let's move into definition of pH and pOH. Now, once you talk about pH, it simply means the scale used to determine hydrogen ion concentration in a solution. Once you hear pH, this is what I want you guys to take note of. Once you hear anything like pH, they are talking about what? Hydrogen ions. Yes, they are talking about hydrogen ions once you hear pH. Now, what is pOH? pOH is a scale used to determine the hydroxide ions in a solution. pH is what? H plus, which is hydrogen ions. Now, once you hear pOH, they are simply talking about what? OH minus, which is hydroxide ion. Now, once we talk about this pH and pOH, we just be saying pH and pOH, but we don't know the full meaning of it. Now, pH is something that we know normally. You understand? It's just potential hydrogen. You understand? Now, we have pOH. This pOH, we call it potential of hydroxide. Now, I want us to understand something. In pH, it's just in this pH, it's just related to acid, but in this pOH, it is related to base. So that is what you need to take note: acidic and base. Because once you define this base and acidic, you normally know that this pH, they are talking about what? Acid, and pOH, they are talking about what? Base. Now, let's look into this relationship between pH to pOH. Now, before I forgot, I want us to understand the formula for this, because we are going to be using it to get the relationship between pH to pOH. Now, let's move. I have something of this pH. Now, it is going to be something of what? Log, which is log minus log. Then you write a what? H plus. This is what they are trying to explain in this. Now, if this pOH, we have pOH, which is what? Minus log, then you write a what? OH minus. Now, this is what they are trying to explain in this. So this is what, because we are going to be using this to derive the formula that we are going to be using to solve this JAMB question. So it is not something of magic. Now, let's look into the relationship between pH to pOH. Now, coming close to this hydroxide ion and this hydrogen ion, can you remember vividly? This can combine to form what we call water. Yes. Let me draw the equation for the reaction. We have H2O. Then we have this forward and backward reaction. Now, I have H plus, then plus what? OH minus. You grab the equation for the reaction. Now, I've written out the equation for the reaction. Now, this is what is left for us to use this to derive what we are going to be using to solve this. Now, let's move. I have this H2O, then H plus, and this. Now, how am I going to be solving this? I'll name this what? KW. Now, what do we call this KW? We call it dissociation constant. We call it what? Dissociation constant. Now, this dissociation constant, we have numbers. We have a number that is constant that we do be using to get this. All you have to do is do what? Follow me closely. Now, I have this. Now, what am I going to do again? Is now equal to H plus, then into this bracket. Remember, there is a difference between using curvy bracket and a closed bracket. Now, we don't use a curvy bracket in this. We use a closed bracket. Now, just note the difference. And also, I have this. So I have written it in such a way that we are going to do what? Know it. Now, we are not done yet. Just follow me. Now, we have KW is now equal to this. Now, what is the next step I should take? The next step I should take is to take the negative log of this. Now, what is the negative log of this? Negative log of this, negative log of this. Now, this is it. I have it to be what? Log KW is now equal to minus what? Log H plus, then minus log OH minus. Now, this is what I mean by what? Taking the log of this. Now, what is the next step I should take? You notice we have a constant. We have a constant in this. And what is the value of this constant? It is, take note of it because I think I don't have space here. Let me just put in the constant here. Now, the constant is what? 1.0 times 10 raised to power what? Minus 14. Because water is something of 25 degrees Celsius once it comes to dissociation constant. Yes. And in that 25 degrees Celsius, we convert it to Kelvin. Once you convert it to Kelvin, we'll be having something around 290 something. Yes. Now, what is the next step I should take? We apply the sense of logarithm, basic logarithm. Now, what is the sense of that basic logarithm? We have this, which is minus log AB is now equal to minus log A. Then minus what? Log B. This is just the basic logarithm we will need to apply to do what? To solve further. Now, minus log AB. I don't need to be writing this because we already have our constant. Now, this is what I will do. Now, I have minus log AB, which is this. Now, if I want to get the logarithm of this, it's very, very simple. Just pay close attention. Since this is already 1, I don't need to press the log of this again because once you press the log of 1 on your calculator, you have what? 0. Now, I'll bring out this minus 14, which is minus bracket minus what? 14. This is what I have. Is now equal to, what do I have again? I have this log A. Now, what is my A? I'll just simply write H plus, right? Then, what will I do again? You know, this is minus and this is minus, which is going to be what? Which is going to be what? Plus. Then, my log what? I'm not going to write log again. I'm going to be writing what? OH minus. So I'm done. Now, what is the next step I should take here? The next step is minus times minus will give me what? A positive 14 is now equal to, now, my H plus, this hydrogen ion, is it pH or pOH? It is what? pH. Is now plus this OH, is it pH or pOH? It is what? pOH. Now, we are done. So if I want to just put it in an orderly form, it is going to be what? Therefore, I have it to be what? P, this is therefore, then pH plus pOH is now equal to what? 14. You take note of this formula because we do be using it to be solving a lot of questions. So you take note of it. Now we are done getting the relationship between pH to pOH. So we are done with definition of pH and pOH and the relationship. Let's look into the exam key points we need to know because I'm going to be listing as bullet points you need to take note of once it comes to pH and pOH. Now, before we look into that, I want us to take note of this, that once a pH is being greater than 7, it is what? It is basic. Once it is less than 7, it is acidic. And once it is equal to 7 on the dots, it is what? Neutral. So, coming to pOH, it is going to be the vice versa of this. Now, what do I mean? pOH, once it is greater than 7, it is acidic. Yes. And once it is less than 7, it is basic. And once it is equal to 7, it is neutral. Now, just take note of this. And also take note that the pH is inversely proportional to pOH. Take note of it. Now, the next thing is this. Take note that once an acid is being diluted, the pH of that particular acid will increase or decrease. Which one? It is going to do what? Increase. Let me explain. Take for instance, I have a concentrated H2SO4. I diluted it with water. Me diluting it with water, will it increase that pH of that particular substance? Yes. Why? Because once you dilute an acid, it is just moving to base. Do you understand? Because the pH again will not be that less than 7. It is going to be greater than 7. Yes, because you have diluted it with a substance. So that is why a diluted acid, its pH will increase. That point must be noted. Now, the next one I want us to take note is that the pH increases with the pH increases and the pOH decreases. The pH increases and the pOH what? Decreases. Now, we are done. Let's solve solid JAMB question. I'm going to be solving 8, as I said earlier, and you yourself is going to be solving 3 as an assignment, and you'll be dropping it on the comment box. Now, let's solve question 1. Alright, now let's solve questions on this pH and pOH. So, if you are enjoying this video, hit the subscribe button, like and share. Now let's solve question 1. The question will be appearing on our screen. The question says, what is the pH of a 2.0 times 10 raised to power exponent minus 5 mole solution of sodium hydroxide? We are asked to calculate the pH of this. Now let's solve it together. It is very, very simple. So now, firstly, what am I going to do? We are asked to get the pH of this. So our pOH is unknown, since this is what? Sodium hydroxide, because sodium hydroxide is a base. Yes, OH is a base. So now, once we hear sodium hydroxide is a base, now we need to get the pOH of it, because sodium hydroxide is related to pOH. Once we hear about acid, it is related to hydrogen, which is hydrogen ion, which is pH. Now, for me to get this, I have it to be what? pOH. pOH is now equal to, pOH is now equal to what? Minus log. This is what I have. Right? Now, it is left for me to get the value of this OH. Follow me closely. Let's solve together. So, I have it to be what? 2.50 times 10 exponent minus 5. So now, what am I going to be doing next? I'm going to split this, because once, you know, this thing is in form of 0.000, but we just converted this in a standard form. Now, this is wash and see what I'm going to do. I'm going to be doing pOH is now equal to minus log into bracket 2.50. Understand this now. 2.50 times 10 raised to power minus 5. I'm going to be splitting it, which is going to be what? Log this minus log 2.50, yes, and what? Minus log minus 5. Yes, it's minus 5. Now, the next thing I'm going to do is I'm going to be looking for the log of this. Now, you'll be asking me, since JAMB don't have this log in their calculator, what am I going to do? It is very advisable for you to know log 1 to 10. They will not ask you anything beyond this. You know the log of this. Now, coming to this, I'll look for log this. Now, once I look for this log 2.5, it is going to give me what? Log 2.5 is going to give me minus 0.40. Now, looking for log of this, it is going to be giving me is equal to minus bracket minus 5, which is what? Equal to 5. So I'm currently done here. So the next thing is just to subtract. Once I subtract this, which is 5 minus 0.40 is now equal to 4.60. I've gotten the pOH. Now the next thing is just to apply that our normal formula, which is pH plus pOH is now equal to 14. This is what I need to apply. Now, once I apply this, my pH is now what? 4.64, 4.60. Yes, 4.60. This is our pOH. Our pOH is 4.60. So this particular pOH is unknown. I'm going to be writing what? pH plus 4.60 is now equal to 14. The next thing is I will make this guy the subject of formula, which is pH is now equal to 14 minus what? 14 minus 4.60. Now, once you subtract, you'll be having your answer to be what? 9.40. So, and option C is correct. Now, let's solve question 2. I hope you understand what we did here. So, just follow me closely. This is very, very simple. Just pay close attention. Right, let's solve question 2. Now, question 2 says, calculate the pH of a solution of 0.0001 mole per dm cube of hydrochloric acid. Option A 2, option B 4, option C 1, and option D 3. Now let's solve together to know which one is actually correct. Now the first thing they ask us is to calculate the pH. Now coming to this, we don't need to use the other we don't need to use this formula again to solve. pH plus pOH is now equal to 14. We don't need this again. Why? Because we are asked to calculate for the pH of the solution straight, and it is hydrochloric acid, so we don't need to use it again. Now follow me, let's see how to solve it. I have it to be what? I have it to be pH, which is pH is now equal to 0.001. Yes. Now I'm going to be converting it to standard form, so we can be able to use it to apply the sense of log reading in this. Now converting this, I have it to be in what? 1, 2, 3, 4. I have it to be in 4 decimal places. I have it to be 4 decimal places, which is pH is now equal to 0, which is 1.0 times 10 raised to power minus 4. Do you understand what I'm trying to do? I need to convert this to standard form. So I've converted it to standard form. Now, I'm going to be using pH is now equal to minus log, then your close bracket, then 1.0 times 10 raised to power minus 4. Yes. Now, the next thing I need to do is just to take the log of this. Taking the log of this, I have it to be what? Minus is equal to minus into bracket minus 4. Yes. And pH is now equal to what? 4. So we are done. This is the final answer. We have gotten the what? The pH of this. And option B is what? Is correct. So question 3. Question 3 says the hydroxyl ion concentration in a solution of sodium hydroxide of pH, which is 10.0, is what? So what they are trying to make sense in this particular question is for us to get the value of pH. Yes, the value of pOH in this question, because pH was given to us. So we need to get the value of pOH. Now let's solve together. So we have it to be our pOH. We are looking for our pOH. So it's going to be pH is now plus this pOH is now equal to 14. This is what I have. So what is the next step to take? I have it to be what? Our pH is what? 10. Then this pOH is unknown and is equal to 14. Understand what I'm trying to do? Making this guy subject of formula, I'm going to be having pOH is now equal to 14 minus 10. Then my pOH is what? pOH is equal to 4. Now I need to convert this in terms of log, because our final answer is in 10 raised to power minus 4, 10 raised to power minus 6. Now how am I going to achieve this? By playing pOH is now equal to minus log of this 4. Yes. And I'm going to be having what? pOH is now equal to 10 raised to power 4. So this is the what? Final answer. And they are done. Now let's solve question 4. Now let's solve question 4. Now question 4 says, what is the pH of a 0.001 mole per dm cube solution of sodium hydroxide? I think we have solved this. It's related to the other one that we have solved. And I'm going to be solving it again so you will understand more better of what I did before. Now, I have it to be excuse me, I have it to be 0.001. This is what I have according to the question. So we are asked to get they said what is the pH? Yes, we are asked to get the pH of this particular solution. Now what am I going to do next? My next thing in play is the pH of this. So it is going to be what? pH is now added to pOH, then is equal to 14. Now I'm going to be converting this. Now before I move on, I need to get the value of this guy first. So what am I going to be in play? I'm going to get the value of this pOH because it is sodium hydroxide. The pOH is now going to be pOH is now equal to minus log of 1.0 times 10 raised to power minus 3. So this is converting it to a standard form. So the next thing I have is pOH is now equal to 3. So the next thing I need to apply here is just anywhere that I see my pOH, I'll put 3. So pOH is now equal to 14 minus 3. Then my pH is equal to 11. And we are done. Now let's solve number 5 question and we will be done. So the next one is what is y in the equation? So you will see the equation on your screen. So which is y is equal to minus log base 10, which is we have hydrogen ion. So now once you see hydrogen ion, because I taught you guys this when we are just treating about the recap of this pH and pOH calculation. Once you hear hydrogen ion, that's simply talking about acid. Yes. So this hydrogen ion is what? pH. Once you hear pH, it is hydrogen ion. Once you hear pOH, it is what? Basic. So I hope you learned something from this particular thing that we have done. And if you learned something, make sure that you do what? You do your assignment. It is very, very important. And I do be checking on those that did correctly well in it. And if you enjoyed this video to the end, make sure you do what? You hit the subscribe button. I still remain Noble, C of Noble Team. See you in the next episode. Bye.